You can use the Clarity deduplication function to discover duplicated or similar data in a project or an external table. Finding duplicated data in a set of data is not a trivial task. Discovering duplications can require that you consider degrees of similarity between data values. For example, a duplicated row may arise from the misspelling of a person's name, which may not have been discovered if you were only searching for identical data. Depending on your requirements, various combinations of columns may need to be analyzed to determine if data rows are redundant. Clarity provides several deduplication settings that allow you to fine-tune your search for redundant data. But we'll begin with the basics, starting with how to run the dedup function and generate results. Running Clarity dedup requires a connection to the TIBCO pattern server. For the Clarity Cloud Edition, this connection is automatically established. When using the Clarity Desktop Edition, you need to set up a connection to the pattern server. From the home page of the Clarity Desktop Edition, select Pattern Server Configuration from the Settings menu. Enter a connection name and the URL used to connect to the TIBCO pattern server. Click Test Connection to validate the connection. Now you can select a project from the Clarity home page upon which to apply dedup. In our examples, we'll be using the Clarity Sample Customers project, which contains 505 rows of data. From the project page, click Dedup to go to the Dedup page. In our first example, we'll use just the minimum settings to produce a result. We'll run dedup against the data in the last name column alone by selecting it within the column configuration section. For each data column that is analyzed for duplicates across multiple rows, a score between 0 and 1 is calculated to indicate the degree of similarity of the compared data. A value of 1 indicates the compared data matches exactly. When checking duplicates, you need to specify a score threshold between 0 and 1 to establish the accuracy of the query. If the calculated final score for the rows you're comparing is greater than the score threshold you've set, these rows are considered duplicates. All other data rows will be considered unique. We'll accept the default score threshold of 0.9. We then click Run to execute deduplication on the last name column. When the duplicate checking is completed, you're directed to the data page. The dedup results are displayed in newly added columns. Note the column containing the dedup score described earlier. Sorting the rows based on the dedup score from largest to smallest reveals several discovered duplications. Each set of duplicated rows are collected into duplication groups, with each group receiving a unique dedup group index identifier with a value greater than 1. A value of 0 in the dedup group column indicates that the row is unique. In this dedup run, there were discovered 8 sets of duplicated values. Note the dedup score for each duplicate. Where it is equal to 1, the duplicated values are identical. Where it's less than 1, there will be some difference between the values. For this run, the default score threshold was set to 0.9. Any similarities between values with a score less than 0.9 were not considered duplicated, and thus they were given a score of 0, and not collected into any duplication group. The dedup is lead value, when set to true, indicates that the row is the first row in the duplication group. Otherwise, the value is set to false. In this run, there are only 2 duplicates per group. However, there can certainly be more. And finally, the dedup row index displays the original index of the row in the project to aid in locating the row in the previous project state. Persons' last names alone are not normally sufficient for identifying duplicates. We can rerun dedup to compare first name, last name, and date of birth as a unique combination. First, we'll reset the data to its previous state using the Undo Redo panel. Back in the dedup panel, we again accept the default score threshold, but we select first name, last name, and date of birth within the column configuration. This will effectively compare all 3 values between rows and assign a total dedup score. The dedup is run. It produces only 4 dedup groups with scores greater than 0. This more restrictive comparison produced duplicates with a higher degree of confidence. Resetting the data again, we return to the dedupe page to consider other options. Suppose we wanted to run dedupe with the same column configuration as the prior one. However, we consider that the first name field may have a wider range of acceptable variations, such as a nickname or an initial. We can use the weight setting to lower the weighting of the first name column in the calculation of the total dedupe score. Column weights are floating point values between 0 and 1. The weight indicates the importance of the column. A weight closer to 1 indicates that data matches in the column are more important. For example, suppose there is a project that contains catalog data of an online bookseller, and it contains 3 columns: author, book title, and book description. A weight of 1 could be assigned to the author and book title, and a lower weight, such as 0.8, could be assigned to the book description column, which is likely to contain more variation, but should not necessarily exclude duplicates. In our example, when the first name weight is lowered to 0.5, the dedupe results discover an additional pair of potential duplicates. Lowering the weight of the first name column increased the total dedupe score of the candidate duplicates, because the differences in first name data had less impact on the overall dedupe score. The result in this case is that one additional set of duplicates matched or exceeded the score threshold of 0.9 set for this run. When we rerun the same configuration with a score threshold of 0.6, additional potential duplicates are discovered. In this introductory presentation, we've described some of the central concepts of deduplication, and we've showed how it is executed against project data in TIBCO Clarity. We've explained the main dedupe computed values and presented some variations in dedupe settings for achieving particular results.